My name is Sebastian, and today I'm going to be talking about defense in depth for blockchain projects and how to add multiple layers of security to your DApp. This basically is applicable to both smart contracts and in some places to your front end. And this slide set has been prepared together with my colleague, Alex Murashkin. So just a short introduction about myself. Been working in the security industry since 2011 at multiple smaller and larger enterprises. Since 2018, I'm an auditor, engineer, and researcher at Quantstamp. And yeah, my hobbies are football, snowboarding, and fast cars. Just a quick sort of summary of today's talk. This is more like a cookbook for how do you improve the security of your DApp. I'm not going to go into any examples with source code or anything like that. So it's meant for developers who want to somehow improve the security of their project. And probably for any security experts out there, this is going to be things that you've already heard before. So starting off with a famous quote, you probably heard this a million times, but a chain is only as strong as its weakest link, right? You hear that a lot of times when you work in the security sphere or when you read about security. But now the problem is like, okay, what do I do about this, right? I don't want to have like a weak link somewhere and then everything breaks, right? So how can I sort of work against and try to prevent that something bad would happen to my chain or DApp or whatever, right? And this is what I'm talking about today. That's the defense in depth topic, where you basically try to add multiple layers of protection, such that if one layer fails, then the other layers are going to be able to be there to mitigate the impact of the exploit. And it looks more like an onion, right? At the base of the onion there, at the bottom, you have your crown jewels, your assets, everything that is important to you, and you basically add multiple layers in order to protect, right? And you can see the attackers coming out from the outside and trying to get to your crown jewels. And if your layers there are secure, then are strong, then the attacker is going to have a hard time getting there, right? That's the idea. And we're going to go through each of these layers in more detail, starting with the development best practices. So here on this slide, we're going to talk about the process. So how do you use best practices for your process? And there's another interesting saying in software engineering that great code starts with great documentation or great technical spec and code comments. And we've seen over the years a lot of really cool engineering masterpieces, which were very hard to audit because they lacked a great documentation, right? And by documentation here, I mean the fact that when you start your project, you should have some basic user stories from which you derived your functional and non-functional requirements. You can also employ various diagrams like use case diagrams, architecture diagrams where you just have some blocks, and maybe interaction diagrams where you show the interaction between different blocks in your architecture and the user maybe as well. You can employ, there's all sorts of visual aids which accompany text in order to help auditors understand what your project should be doing. And on top of that, of course, you can, you should have sufficient code comments describing what the purpose of various functions, state variables, constants, modifiers, whatever you want are. And also for functions, you should describe what each input should be, maybe even indicating what the range of the input should be and the range of the outputs. Because this is going to be very helpful to auditors and testers when they go through your project, as well as for maintenance. So another very important aspect related to process are pull requests that should be created for each feature. And you should require at least 1 or 2 peers, developers, to approve that pull request after manually reviewing the code before it is merged. Otherwise, you might get, yeah, unreviewed code, which is always bug prone. Moreover, each pull request or feature should have tests accompanying it. So you shouldn't have pull requests which are dedicated to just business code and pull requests which are dedicated to tests. That basically will lead to the fact that only business related pull requests exist unless you do them somehow in parallel and you have a QA team and a dev team which does them in parallel. But if you have like a small shop where you don't have a dedicated QA team, it's always good to have tests as part of your pull requests. And one thing which is important is whenever people build your project, all dependencies, all the versions, even your Pragma versions for Solidity and something like that should be locked, such that if there's a bug occurring due to a specific version, that everyone else can reproduce it. And if you don't lock these things, you're going to have issues reproducing bugs on different platforms for different developers. When someone else tries it, it's going to be different. Moreover, from a security perspective, if you've done all your testing and development somewhere last year when you had specific versions and you didn't lock them, and now you do a redeployment this year when a lot of different dependency versions have changed, maybe your product will be behaving differently and could lead to exploitable vulnerability. So that's also something that you should keep in mind. You should be deploying the same thing that you've tested. And one thing which I've noticed recently is that, especially in the blockchain space, is that some projects like to fork code from some famous projects which have been very innovative, and they modify these forks and they ask for an audit of the diff between the version that they forked and all their modifications. Now, the problem there is that sometimes the fork is not made on a commit hash which has been audited before. So it's the project which they forked from was indeed audited at some point, but the commit that was forked was not audited. And sometimes it's very different from the commit which was audited. Just wanted to put this out there that there could be a lot of bugs introduced between the commit which was audited and the one which was forked. So be careful when you see something like that, when you're trying to fork things, or when you see projects which have forked, just check that they have forked a secure commit. Going further to the coding best practices, because on the previous slide we talked more about the process. These basically are like a top 10 list of best practices from the Carnegie Mellon University Software Engineering Institute, CERT. And they have these 10 recommendations that apply to any programming languages, any environment. And the first one is that you need to validate all the untrusted inputs and data sources. Basically, whenever something is like in Solidity, an external function, a public function, which takes inputs from an end user, that end user could be malicious. They could input anything in there. And this also applies to your DApp, right? If you have a DApp which takes some user input and maybe converts it on the front end and then passes it to the smart contract, beware that users might try to insert something which is like in the front end, you could insert something which is cross-site scripting exploit. So always validate untrusted inputs. Don't trust anything from end users. This one, the second one, is something which you see very often. When we do audits, we always compile the code, we run the tests, and sometimes you see a lot of compiler warnings, which really are sometimes vulnerabilities, right? Like people say, oh, if it's just a warning and it builds, then it's not a big deal. But sometimes it is a big deal. So you should carefully pay attention to what these warnings are saying and try to fix as many as possible. And if some of them are not fixed, be sure you understand what they mean and that they don't have any impact on your product. You should also architect and design for these kind of security policies such that you have different roles and you know which roles are able to access which functions. And by default, you should deny access to everyone. In Solidity, this is very hard because in Solidity, you actually need to add modifiers to a function to restrict access because by default, everything is allowed. So this best practice, number 4, is actually is very difficult for some programming languages and for some paradigms. And we see this very often as a problem in this space of smart contracts and dApps. So be wary and try to design this in a safe way. Another one, which is my favorite, is the KISS principle. So keep it simple. The second S is for stupid. So keep it simple as much as possible. Don't try to make very complex code just to show that you have the ability to do so. Simple code is beautiful code. And this is also related to the previous ones. You should adhere to the principle of least privilege. So you don't have to give someone access forever. They should get access for a certain restricted amount of time, after which they don't need that access anymore. You should take it away from them, right? In addition to validating inputs, you should also sanitize all the input data. And this also applies to your front end. When you send the input that is given by the end user to your smart contracts, be careful to sanitize that and don't feed garbage to your smart contracts. And the thing that we're talking about today, defense in depth, you should also practice that and use effective quality assurance techniques such as automated fuzz testing whenever possible. And the last but not least, you should always define your security requirements and model your threats. And if not, and if you don't have the expertise to do that, you can definitely find consultancy companies such as Quantstamp, which can help you do that, even before the audit, even during the development process. The second layer is automated testing and scanning. So here you can leverage the power of continuous integration systems to do a lot of stuff for you automatically. You can run all the tests that you have written for each code push and mandate that everything passes. You can check that the branch coverage is higher than a certain number that you want. This ideally should be 100%. You can run a lot of static code analyzers and mandate that everything is either resolved or marked as a false positive. And you can also run linters that make sure that everything is formatted properly, that the complexity of the functions is not extremely high, such that you can still adhere to that principle on the previous slide, the KISS principle, such that nothing is extremely complex, right? And the reason why number 3 is made italic here is that we had like an interesting project with a large enterprise, a large conglomerate in Germany, where we developed exactly this kind of system that integrated with their CI, and they were able to get the numbers of faulty code in their system down by at least 50%. So this is really important that you leverage the power of these CI systems, right? And you can do more, you can add more rules in there. And basically, you can ask the CI to block any pull request merging before all these rules are satisfied. Moving on to the next layer, the white glove security audit. So this process, this image is taken from our website, and it shows our current process. And I'm going to walk through all the suggestions for each step. So the first thing you have to decide is the level of your white glove security audit. If you want to do just a high-level review, if you want just a manual audit looking through each line of code, or if you want very formal stuff like a formal verification of your code, these are definitely very different grades of security that you're employing there, different amounts of effort required, and probably a different timeline, right? So we can do all of these, and you need to say this up front before we can start making the quote and everything else. Ideally, the code that we scope and the effort that we estimate should be exactly the same as the audited code. Now, sometimes this doesn't happen because projects want us to scope maybe a few weeks to months in advance, or a month in advance before they are ready, but the magnitude maybe of the code doesn't change that much, so the scope is pretty much the same. You should set up a communication channel between your developers and the auditors such that everything can be clarified as fast as possible, and there's no blockers for the auditors. That is going to reduce the timeline for the audit. You should walk the auditors through your code once, just before the audit starts. So it's good to tell them like, hey, here's where the most of the business logic is located. These other files maybe just have boilerplate stuff in them, such that the auditors have some orientation of where your code is. And especially if it's a huge project, like a layer 1 solution that has multiple subdirectories and they're named funny, then you might want to walk your auditors through that. Well, this is really important, relates to one of the first things I mentioned in the presentation, the documentation. You should give auditors the most succinct, so the shortest but sufficient documentation. We've had projects which gave us like tons of papers they published, websites, multiple websites, community documentation, internal documentation, and so on, right? And that was too much. And we also have many projects which gave us no documentation, right? Documentation is meant to ramp up the auditor with what your code should be doing, and for them to be able to quickly verify against the documentation, the implementation against the documentation if something is not working properly. A really good example of good documentation and sufficient documentation was that which we got for Prism, from Prismatic Labs. We could really easily map the specification of Ethereum 2.0 to the implementation there, even like to the level of the fact that the names of the entities in the documentation were mapping to the names of the variables in the code. So that was great. And last but not least, once you've received the report from the auditors, you should respond to all these issues either by making fixes or writing some text with the fact that, oh, we acknowledge this issue, but we don't want to fix it because whatever reason, as soon as possible. The faster you respond to the auditors, the sooner they can do the re-audit of the fixes, the fresher the things are in their minds, right? If you come back after a month, 2 months, all the auditors might have already forgotten the mental model that they built for that audit. So it's really important to come back as soon as possible. And last but not least, in the certify phase at the end, you should ask the auditors to publish the audit report on whatever platform they have, such that it's a third party which is publishing the report and it's not you, so that people maybe don't trust that you might have tampered with the report or something like that. So it's better to ask someone else to publish the report, and then it's more trustworthy. The fourth layer of defense is monitoring and incident response. In this case, you should define whatever you want to monitor, and this is really easy after you've done an audit, because during the audit, these kind of things that are worth monitoring have been pointed out by the auditors. You should decide what you want alerts for, right? Once you know that you're going to get alerts, you should also decide how are you going to respond to each of these alert types. And just to give you an idea, there could be different alert types. A bug could be found internally by the development team while testing or whatever, doing something. It could be a responsible disclosure by a white hat hacker who wants a bug bounty. And then you have like 90 days to respond. So you have some time to think about the solution and try to do it as smoothly as possible for your end users so that it's totally transparent and they don't feel a thing. And it could be an exploit of your live system. So in this case, you don't have any time. You should respond as soon as possible with a temporary fix, and maybe then you deploy a more permanent fix. It's always difficult with smart contracts because they're not so easily updatable as other types of software. When you respond to incidents, you shouldn't have like this delegation like, oh, this was not my part of the code, I don't care about it, I push it to developer X who wrote that code, so I don't care, right? You should do it collaboratively with as many people as possible, and you should involve the auditors, right? We have this kind of situation sometimes that some of our clients ping us on whatever communication channel we had set up during the audit and say, hey, some of our community members or developers have noticed this, can you please take a look? And we immediately respond like that's like something which is our highest priority. So even if we have a lot of audits, we're booked all the time, if we get one of these kind of pings from our customers, we basically get it to the highest priority and look at that, right? Because the funds of the end users could be at stake. And once you've responded to an incident, might that be successfully or not that successfully, you should have these kind of post-mortems, post-incident reviews, and try different ways, look at, do a reflection and improve your process. Now, last but not least, you should employ automated monitoring and alerting tools and services. And just wanted to give this as an example. We have the Quantstamp monitoring service, which monitors every block, every transaction for different types of issues, right? And you get an alert. You can get an alert on email, mobile phone, or you can just use the API and hook it into your system so that you can freeze your contract or pause it or whatever once an alert is hit, right? So you should do all as much as automation as possible here as well. The last layer is insurance. And in the case of insurance, like if all fails, you should make sure you're covered. Here you can decide whether you want a business-to-business insurance policy where all of your funds are insured, and in case of a hack, you are responsible to distribute the proportional amount of funds to your end users. But better yet, you can do a business-to-customer policy where each of your end users of a DApp, are able to opt in to buy this policy when they deposit funds or provide liquidity or whatever, or they can decide not to buy it, right? It's up to them. There's a big difference here because some insurance companies, traditional insurance companies, they basically have licenses for different countries, right? And they can only insure people in a specific country or a platform in a specific country. So this is really important if you talk about traditional insurers. And here's the second point, actually, a segue to that. You can decide between crypto native versus traditional insurers, right? So in crypto native, we're seeing a lot of innovative solutions there, right? Where we have like a bunch of them, like Nexus Mutual, Open, Cover, right, and so on. Now, the problem there is that those could also have bugs, right? And they could be exploited, which was happened in the past. And at that point is like, who insures the insurers, right? At that point, you might say, hey, maybe I want to get a coverage from a traditional insurer where I need to like do some paperwork, but I know that they won't get hacked. The insurer won't get hacked, right? So that's also up to you to decide. You can also determine what trigger condition would be for like a claim. Would this be automated based on some Oracle data, or would it be manual? Like maybe there's a vote with a specific quorum of people who have tokens, and they vote whether this is a legitimate claim or not. There's trade-offs there, of course. You should tailor, if possible, your policy as much as possible, like to include as many events as possible, right? You want to be covered in many cases, and all of the things that we look for audits, you can include like different types of attacks. You can include 51% attacks. You could include attacks of the oracles which you're using, but you could also exclude them. And this is going to have an impact on your premium price, right? And you try to reduce the premium price as much as possible by employing defense in depth. As a conclusion, defense in depth basically is multiple layers of protection. And just to do a parallel, coding is like wearing a mask and social distancing. Automated scanning is like PCR testing. White glove audits are like vaccines. Monitoring is like temperature measurement, and insurance is like medical treatment, right? So yeah, that's it. Thanks a lot for your attention.
Thank you so much, Sebastian.